Hello everyone, welcome to CivilPrep. I am Krishna Gupta. We are continuing this session with respect to the mains 2025, okay, for geography optional. So we have already discussed up to question number 3B. So here we'll be starting with question number 3C. So the question is asking here, the Himalayas is still rising. Expand the statement and describe the processes involved in it with suitable sketches and examples. Now, when we look at this aspect here, the formation of Himalayas, it is very well explained by the plate tectonic theory. This theory, it was given by Morgan, Wilson, Mackenzie, and Parker. Okay, where we see that the Indian plate and Eurasian plate they collided around 35 to 40 million years ago. And the Indian plate is still subducting under Eurasian plate at the rate of 2 to 3 centimeters per year, due to which the Himalaya its altitude is still rising. Okay, so under this introduction, we can provide the development of the Himalayas, and we can see that how this is actually happening. Now, we need to actually provide here that what are the processes which are actually taking place due to which the Himalayas are still rising. So here we'll be seeing the factor as this is the Eurasian plate. This was a Tethys Sea, and this was Indian plate. So here we see that this is a continental plate, this is an oceanic plate, and this this is also a continental plate. Continental plate, but this part of Indian plate, it is an oceanic plate. This is Tethys. Okay, so here we'll be seeing that this is also consisting of a plate here. Now this plate, it is actually subducting. Now, when we look at the motion, the type of motion which is taking place here, this is a convergence motion, or this is a convergence plate boundary. Okay, this is a convergence plate boundary, and this is the asthenosphere. Now, under this part, we need to analyze that what is actually happening in the contemporary time. So we will see here that at one point of time, number one, the Tethys is completely subducted. Okay, so here we are seeing that there is also formation of an accretionary wedge because of the deposition of sediments. So this is accretionary wedge. And at the other point, we will see that there is magma which is uprising here. And because of this magma, the volcanic mountain is formed. which is currently a part of Karakoram. Okay, it is part of Tethys Himalayas. Sorry, not Tethys Himalayas, Trans Himalayas. Okay, now here we'll be seeing that there is an accretionary wedge is formed and there is also formation of a Trans Himalayas. But after a certain point of time, this Tethys plate, it is completely consumed and subducted. And number two, there is a direct collision of the Indian and Eurasian plate, which have resulted into the formation of suture zone. Under the suture zone, we'll be seeing that this is explained by the elastic rebound here. Where we'll be seeing that there is a deformation in the plate, and here the Karakoram ranges, okay, the Karakoram ranges, the Ladakh ranges, and the Zaskar ranges, they become part of the Trans Himalayas, okay, which is also consisting certain part of the accretionary wedges here. And certain accretionary wedge, it is also deposited over the Great Himalayas. So here we have the Great Himalayas. After the Great Himalayas, we have Lesser Himalayas, and then we have Shivalik. Okay, and here the plates, they are continuously deforming because the Indian plate, it is still being pushed, and there is certain remnant of the convergence motion here, and due to which 2 to 3 centimeters per year. This is the rate at which the plate is currently moving in the contemporary time. Okay, so in this way, we can explain that why this phenomena is happening, what were the previous experiences with the Himalayas. So we are able to explain this part very well here. Okay, now moving to the next aspect, expand this statement and describe the processes involved. Okay, expand this statement and describe the processes involved in it with suitable sketches and examples. So here we have explained the development of Himalayas. Okay, and here we need to explain that what is currently happening here. So we will see here that these Himalayas, now they are actually part of one single continent. This is the part of Tibet or Tibetan Plateau. And this is acting as a single plate. This is Eurasia. Okay, so here we have the part of Indian plate. As the plate is being pushed, okay, one of the characteristic of plate, that is, it is acting as a stress guide. So when a plate is acting as a stress guide, for example, there is pushing of the plate is happening from one end. So the complete stress or the complete force or stress will be transferred from one end to another end. Therefore, we see that there is no deformation of plate in between, but the plate is still subducting, the plate is still moving forward, which is resulting into the rising of the Himalayas in this aspect here. So this is the stress guide mechanism, due to which all the forces which are being given from one end, it is transferred to the another end here. So this is also explained by the systems, okay, systems analysis through this part, which explains that why these Himalayas are rising in the contemporary time. Second thing we'll be seeing here that there is still a convergence motion. So this convergence motion will be seeing that it is happening because of the convection current. Okay, this is happening because of the convection current, as we can again see it in the diagram, which is taking place beneath the Eurasian plate and the Indian plate here. So this convection current, this have a particular rate of movement, which is being decided by the magma movement, where we see that here the rate of subduction is quite slow as compared to the Pacific plate, which have a rate of subduction of 8 to 12 centimeters per year, or the rate of movement of 8 to 12 centimeters per year. So in this way, we are again able to understand that why this plate, it is moving in a slow direction or in the slow pace here. Then next thing we can see here that describe the process involved in it with suitable sketches. So here we can see that we are able to explain that how these things are happening, how the rising is taking place, what are the mechanisms which are involved here. Okay, here only we can add up here. There is presence of convection current. This convection current is having a convergence motion. Okay, and here we can again see one thing, that the motion of plate, this is mainly happening because of the we can say the radioactivity and which is taking place inside the asthenosphere. Plus also we can see here that the plates, they are actually taken up as they are getting friction from the below moving magma. So in this way, we can explain that what are the actual phenomena which is actually taking place inside these plates here. So through these diagrams, we can explain that what is actually happening here and why the Himalayas are still rising in the contemporary time. Now, what can be the way forward and conclusion? So here we can see that number one, currently the volcanism is absent. Why? Because the part of Tethys plate has moved away from the Eurasian plate. Okay, so because of this, the volcanism is not present in the contemporary time. Number two, the region of Himalayas. This has resulted into the formation of several faults. Faults, if we look at, it can be symmetrical, actually fold and faults, symmetrical, it can be recumbent, it can be, we can say, napes. So here we can see that there is presence of central thrust fault, then main boundary thrust. Okay, so central boundary thrust, main boundary thrust, etc. These are certain faults which are present in the Himalayas where the folding has actually taken place, and they are also one of the evidences which are provided here. Third thing we can see here that this region is very highly susceptible to the earthquakes. So recently we'll be seeing that in the region of Nepal, in the region of Afghanistan. Also, we will see that in the region of Uttarakhand and Northeast India. We experience series of earthquakes because a large amount of energy is stored beneath them. So we will see that the Himalayas, they are consisting of certain seismic gap. These seismic gaps are important to study the boundaries where we can see that the earthquake may occur. Okay, so in this way we can conclude our answer with a way forward or a conclusion. It is up to you that how you frame that particular answer here. So we can see that this is one of the question which is quite important, consisting of the plate tectonic theory, and it is also suitable for the planning in the region because Himalayas is still a fragile region, as we can see it here. Okay. Now moving to the next question. Next question is, what are the ecological consequences of agricultural deforestation in the Amazon and Congo basin, particularly concerning biodiversity and climate regulation? So this is one of an important question. This is here we can see that it is from the environmental geography. So first thing we will see here that what is the deforestation in Amazon and Congo basin. So this Amazon and Congo basin, they are consisting of tropical rainforest. Okay, so this tropical rainforest, majorly of the Amazon, they are the lungs of the world, adding almost more than 40% of oxygen every year. Okay, so one thing we can see here that this is very important here. Nextly, if we go through the report of UNCCD, so here we'll be seeing that the rate of deforestation in the tropical rainforest region, it has almost rise by almost 50% since the 19th century. Okay, so this is one of the data which we can add here to support our answer. Okay, now when we look at the deforestation in the Amazon and Congo basin, we need to provide a map here. So in one part, we can add a map of these two regions. So here we'll be seeing that this is a particular region where we find the presence of the Amazon basin. And this is the region for the Congo basin. Note that they are very near to the presence of equator. So we need to highlight this part, and they are consisting of tropical rainforest. Okay, the major river which is present in this region, this is Amazon River, and this is the Congo River, which is present here like this. Okay, now looking at back to the question again here, the ecological consequences of agricultural deforestation. So number one thing we'll be seeing here that the deforestation, it is majorly happening because of the growth of various plantation crops like palm oil or palm, cocoa, rubber, coffee, etc. Okay, so this is one aspect which we see here. Now, when the deforestation occurs and these plantation crops are being grown in this region, we will see here that whatever the biodiversity, for example, in the Congo basin, there is different biodiversity, and in the Amazon basin, there is different biodiversity. In Congo, we will see that there is presence of various elephants, rhino, okay, then we have tiger, etc. In Amazon region, we have the presence of puma, then we have jaguar, elephants, etc. So because of this, what we see that there is loss of habitat. So according to a report which is being provided by FAO, okay, UNFAO basically it is every year 10% of the tropical rainforest it is being cleared for the plantation crops. Okay, so this is one of the data which we see here, which is happening every year. Third thing will be seeing that because of the loss of habitat, these species, they are actually looking at the migration. Because whatever the, we can say the, just give me a second. So migration is taking place in this region. The animals, they are migrating to the various other regions. Okay, for example, they are migrating into grassland. But in the region of grassland, we'll be saying that, or they are moving to the interior of forest. So because of this, what is happening here? There is interspecies and intraspecies competition. So the interspecies and intraspecies competition is rising in this region here. Because of this, the species, they are moving towards the extinction. Okay, they are moving towards the extinction. Third thing we'll be seeing here, the limits are getting reached in terms of food, habitat, water, etc. So we will see that this limits, it has been very well explained by Liebig. Whenever the limits are reached, it again results into the rate of increase of extinction. Okay, this is again increasing the rate of extinction. Number 4, we can also apply the law of tolerance, which is being provided by Shepherd. So according to him, what we will see that the species which are present in this the tropical rainforest region, here they are having a particular precipitation, temperature, and their niche area. So when they are moving out of it, their tolerance is breached. So when their tolerance is breached, again their rate of extinction, it is increasing in this particular region. Okay. Now, after this, we can also look at the biogeochemical cycle. Okay, because of the destruction of forest, whatever the carbon cycle, then the oxygen cycle, then we have carbon cycle, oxygen cycle, then water cycle. These are the few important cycles which are associated with, they are getting disturbed. Okay, oxygen will be seeing that it is declining. Carbon, it is increasing in the atmosphere. The active carbon is increasing. The water cycle, it is becoming more extreme. Okay. Apart from this, we can also look at the law of succession. This is provided by Clement. So here will be see that under the law of succession, the tropical rainforest, when they are degraded, either they are converted into the deciduous forest or they are converted into grassland. We will see that in the Congo basin and the Amazon basin, the tropical rainforest is majorly getting converted into grassland. Why? Because the grasses are there quite common, and in the nearby areas, they are quite very high here. So due to which we'll see that the habitat of the animals or the biodiversity which is living in those tropical rainforest region, they are not able to compete with the animals which are living in the grassland region, and this is happening because of the law of succession here. Now, apart from this, we will also see that there is a homeostasis mechanism. Okay, homeostasis is basically whenever there is a change in input in the environment, the output also changes, and this is also connected by a feedback mechanism. So under this condition, we'll see that because of this feedback mechanism, the change is becoming positive here, for example, with respect to the climate change, and its output is also increasing with time. So this in under this condition, what we are seeing that these tropical rainforest, okay, they are witnessing increased deforestation, increased climate change, increased, we can say, the loss of habitat. So it is acting as a positive feedback mechanism. So under this positive feedback mechanism, the biome, it is not able to self-regulate it. The self-regulation is not being seen here. Because of this, what we see that it is resulting into the transition of biome. Okay, from tropical rainforest into grassland. Okay, so guys, we can see here that we have certain aspect here for the biodiversity and climate regulation. So for the climate regulation also, we can see that we can use the biogeochemical cycle, the law of succession, the homeostasis mechanism. And here when we look at the climate regulation, we have certain type of climatic forcings. So under the climatic forcings, we have internal and external. So under this part, looking at this aspect here, this is majorly combined with the internal factor where the anthropogenic causes. Okay, such as deforestation and land use change. This is basically seen as one of the factor which is changing the climate here. Okay, so climate change is being seen in this particular aspect, because of which there is again a positive feedback mechanism is seen with the temperature rise, and this temperature rise is having various effect over the climate. That is wind circulation. Then we can say here the weather is becoming extreme. Okay, for example, droughts, and floods. Droughts and floods, they are becoming extreme here. Winds, we will see that they are moving quite fast in certain region and they are getting slow in certain region. The moisture presence, the moisture or the relative humidity, it is also getting extreme. Near the coastal areas, it is very high. While in the interior regions or continentality, it is becoming very low. So because of these factors also we'll be saying that it is resulting into the changes of various climatic aspect here. Okay, so guys, we can see that we can conclude this aspect here, conclude this answer with respect to the 30 by 30 by 30 initiative of CBD, that is Convention on Biological Diversity, so that the habitat and the biodiversity is maintained. Okay, so guys, this is a question which we see that this is for 20 mark and this is from we can say the biodiversity and the part of the environmental geography. This is quite mixed here. Okay, so moving to the next question. So examine the distribution and balance of energy in the Earth's atmosphere system. Okay, so here we have Astha. Hello, Astha, how are you?
Hello, sir. Good evening.
Good,
Good afternoon.
good afternoon. So how are you doing?
I'm doing well.
Okay, so do you have any doubts or queries in this particular answer that we have taken up here?
I just wrote the brainstorm the paper one. Sir,
Hmm.
I face difficulty in that NAP question. Like
Ne-
I know what is NAP, but the tectonic and geomorphic or geological importance, I am not able to wrote that answer. And
Okay,
also one that question of so there was one I'm forgetting. So there are some questions I'm not able to like how to write or how to brainstorm. I know just the term.
if we have various questions here, we can go through this. You will be able to understand what are the questions. Then
Yes,
we
sir.
can have a discussion over them. You can just say which one it is.
Okay, sir. So also the air mass and local wind question. I saw your explanation, but still I'm not able to wrote that answer.
Okay, air mass and the local winds. Basically, we need to
Yes.
have a, actually, we have seen that what are the air mass and where they are formed, and high pressure system and low pressure system over the land and oceans. Okay, so in one,
Okay.
actually, I have taken the
And yes, sir.
I have taken this approach. You might have seen my explanation.
Yes, sir. I have seen your matlab, all the explanation of paper one,
Mhm.
and I just note jot down the points that are missing in my answers.
Okay.
Okay, and the second question is oil question, that oil important for energy security. I am not able to wrote that it is about bio oil or just natural oil or what it is asking for and how it is for clean energy, because ultimately the source is extraction and it is polluting in itself. The extraction or processing is in itself polluting. So that question also.
It is of economic geography, I think.
Yes, sir. That the question in the second part.
Okay, not an issue. What we will do here, in the evening, I'll be taking the explanation for the part B because actually I have less time right now. I am doing a lot of things together. So don't worry, I will be taking an explanation today itself. It will begin by 7 p.m. Since 7, it will be stretched up to 10 or 11 until the paper is completely discussed. Okay.
Okay, sir.
Okay, so by that time we can have a discussion over this answer. Okay, so were you able to answer this question very well?
Sir, it's more about the heat budget of the Earth. heat budget, and then that the meridional circulation of the air or the heat balance over the how the like from its surplus area or and deficit area.
Deficit area. Actually, this is a very static question. So there is
Okay.
nothing new that we can add in this question. Okay. So I'll just give an approach here. So approach, what we need to do here, we need to have two areas where we are looking at. Number one, the heat budget in terms of atmosphere, and the heat budget basically from the latitudinal zones. Okay, so under the atmosphere part one, what we see here that we have two areas here. Okay, in the first aspect, we have the incoming solar radiation, that is insolation. So out of this insolation, now you tell me what are the different components which are either scattering or they are being reflected back. Okay, so by
Right.
the atmosphere, there is a scattering phenomena. So here we'll be seeing that there is almost 6 units. Okay, insolation, there is, we can assume it is 100 units. So 6 units, it is going back because of the scattering. By the clouds, how much it is going back?
From clouds, it's around 6%. I think I'm not able to recall.
It is 27 units.
Okay, okay, sir.
Okay, then here again we'll be seeing that almost
So,
around 2 units. Yeah, speak.
no, 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 sir, no, sir.
Okay, 2 units, it is going back by the albedo phenomena. And within this, the 14 units
Is absorbed by atmosphere.
is absorbed by atmosphere. So we will see that the amount of insolation which is absorbed by Earth's surface, this remains up to around 51 units. Okay, then here we see that we have the going out of these 51 units in the form of terrestrial radiation, which is taking place in the form of conduction, convection, and
Radiation.
radiation. How many units is going back by the radiation? It is around 17 units.
Okay.
By
Sir,
conduction?
okay, okay, from atmosphere.
Yeah. What?
Eh,
No, I didn't understand what you said.
No, sir, I just like confused among the values, like 6% from the radiated from Earth. So I that makes that two concept like from atmosphere or from Earth.
Albedo, basically it is the ice surface or the ice region of the earth which is reflecting back these 2 units. Okay, so that is surface majorly where the reflection is taking place. So this is majorly reflection. That is 2, but it is directly, there is no kind of absorption is not taken place here. Okay, then convection will be seeing that it is around 9 units. Okay, so 9 and 17, it is around 26. Okay, so how much we have left here? It is around 23 units. It is going back by the process of conduction here. So what we see here that plus this 14 units, plus this 14 units which is absorbed by the atmosphere, it is again going back. Okay, so this is giving us a heat budget of Earth. Okay, that is 51 units plus 14 units. equal to 51 plus 14 units in this aspect also, which is absorbed by the surface and atmosphere. Okay, so this is given by the surface and this is by atmosphere. So this is actually the heat budget and heat balance of the earth. Now, when we go for the latitudinal variation, here we see that we have a region of deficit and we have a region of surplus. So here we have 40 degrees latitude to 40 degrees of latitude. So here we have surplus heat. And this is the deficit heat region. And these are the heat deficit region. Okay, so here we see that because of number one, the trimeridional circulation, number one, number two, because of the cyclonic activities that can be tropical or temperate, plus anticyclonic activity, plus the oceanic circulation. Okay, so all these things, they are mixing or exchanging the heat. Exchange of heat between the surplus and the deficit region. Okay, surplus and the deficit region, which is actually resulting into the balance of heat. So we can give in the conclusion part that because of the climate change, okay, we see that the carbon dioxide, it has moved out from around 373 parts per million, okay, almost around 1780s, up to 434 parts per million in 2025. Similarly, we'll be seeing that for the methane. Okay, it was around 780 parts per trillion. Okay, it has come to around 1340 parts per trillion, 1780 up to 2025. So this is also increased here. So because of this phenomena, what we are seeing that there is the stay time of the insolation, not basically insolation, but the stay time of heat. That is terrestrial radiation or outgoing radiation has increased, resulting into the global warming. And this global warming, it is seen as an effect in the part of climate change. Okay, which has also been specified by the 1.5 degrees Celsius special report in 2025 by IPCC. So through this part, we can give the conclusion that is what is happening in the contemporary time and how it is changing the complete picture in this part here. Okay. Any doubts, any queries here? Okay, so next question here we have described the process of formation of barrier islands and explain their significances. So barrier islands will be saying that they are the coral reef islands which are formed by the which are explained by, we can say, Murray, then Daly, then we have Davis, etc. Okay, so these are the coral reef islands, okay, which are formed near the continental shelf region. Okay, under continental shelf, they are present exactly below the littoral zone. Okay, they are present between the littoral zone and aquatic zone up to 200 meters from surface of ocean. Okay, now when we look at the formation process, okay, we can refer to either Davis or we can refer here to Murray. So what they have said that whenever a coral reef is formed, okay, this is the high tide zone, this is the low tide zone. So we will see here that there is presence of coral reefs here. So first there will be formation of fringe reef. Okay, number one, the formation of fringe reef will take place. But what is happening here over the oceans? There is presence of tides or waves. So these waves, number two, the wave action, it erodes. It erodes the coral reefs and it extends them towards the oceans. Okay, so we will say that this process here, it will take place almost like this. So here there is erosion has taken place and here there will be again development of coral reef and the coral reef will expand. Then there will be extension, erosion of the coral reef will take place and their area or their region, it will expand here. So in this way, what we see that as the reef, in number three, as the reef, it extends towards oceans or ocean sea. This results into the formation of barrier reef. Okay, so in this particular aspect, okay, here the Murray has specified one term here, a condition. So condition was, it is up to 57 meters, up to which the fringe reefs can be formed. Okay, but this 57 meters criteria, was not applied to the barrier reef. So this barrier reef, they were, again, we will see that they were extending very high towards this region. So we see that this extension, it takes place majorly because of the skeletal remains of the corals which have been deposited by the wave action after erosion. So basically this is forming a habitat for coral reefs and their expansion. So in this way, we see that there is development of a barrier reef. Okay, there is development of barrier reef. Now, when we look at the significance, their significances. Okay, before significance, I would like to address the case study. of the Australia. Okay, so here we have towards the northwestern part of Australia, we have the presence of the Great Barrier Reef. Okay, this Great Barrier Reef, they are extending more than 100 kilometers towards the sea. Okay, so this extension of this Great Barrier Reef, it has made it one of the very important place where, number one, the biodiversity is very high. Number two, as we see that the coral reefs, they are said to be the rainforest of ocean. So therefore, there is various activities and ecological functions are performed in the region. Third thing we'll be seeing here, they are acting as carbon sequestration. Okay. They are acting as habitat for the various benthic and neritic fishes and organisms. Okay, they are also very good for the fishing activities. Okay, they are also very good for the fishing activities in the region. And this is also very good for the tourism. Okay, so these are the certain significances of this reefs or the coral reefs or the barrier reefs. Now, when we took our look at the conclusion, so in 2025, we will see that according to the report of IPCC or UNEP, or we can also look for the International Meteorological Organization, the marine heat wave. Okay, they have resulted in mass, or we can say the 6th mass coral bleaching event, which is threatening the coral reefs of world. Okay, so this answer we can take up here as a part of the question, which is signifying the process of formation of the barrier islands and explaining their significances in the various aspects here. Okay, so guys, this was a discussion for the answer which we have taken up here. Now, moving forward, in the evening, 7 p.m. we'll be starting the discussion for paper 1 part B. Okay, so guys, see you in the evening. Good day and take care.